Singularity.
Hello, everyone, and welcome to another edition of Singularity One-on-One. Singularity One-on-One is a regular podcast feature of Singularity Weblog, where you can go and listen to it or download it in full. As you may already know, my name is Nicola, aka Socrates, and as always, I will be the man with the questions. Today, my guest on the show is David Ferrucci. Dr. David Ferrucci is the team leader behind IBM's Watson Deep QA project, and I am incredibly grateful that he took time out of his busy schedule to be with us here today. So without further ado, welcome, David.
Hi, how are you? Pleasure.
Fantastic. The pleasure is entirely mine. So let me not waste this opportunity and jump right into the interview. David, before we get into the meat of the matter here, I'd like to sort of open the door on my guests' background and motivation behind what they do. So let me start with this kind of a more general question. David, how did you get interested in technology in general and artificial intelligence and voice recognition or speech recognition in particular?
Well, first of all, let me say that, the Watson is the Watson that you saw play Jeopardy is less about voice and speech recognition as it is about natural language processing and natural language understanding. There is a text-to-speech component where, Watson had its responses and it converted the text to speech, and we had a team that helped us do that. But my leadership and my team was really focused on trying to understand the natural language question, the natural language content from which answers and evidence and probabilities came from. And it was really less about the speech stuff. My background is more in classic sort of AI, knowledge representation and reasoning, and natural language understanding. I got into that going way back to high school, frankly. I was originally pre-med, meaning, I was trying to become a medical doctor. And that was kind of the vision that my parents had set up for me. And one summer, my dad was distraught that I didn't have enough to do because he was always pushing me to study. And I was trying to explain to him, that summers were off. He didn't quite accept that. And there was a course at a local college, an advanced math class. He said, why don't you go take the advanced math class? And this was in the mid-'70s, and the advanced math class was really a computer programming class. And they were doing basic programming, and they had just gotten CRTs, cathode ray tubes, and they still had the line feed printers and stuff like that. And I went there and I started taking programming, and I was completely blown away. I mean, even though we were doing very simple programs, I was completely blown away with the concept that you can imagine something, some procedure, some algorithm, some set of instructions, and you can tell the computer what to do, and the computer would dutifully carry out those instructions. And, just my mind just lit up on the possibilities and the implications of it. And frankly, it immediately went to the idea of artificial intelligence, immediately. Because I was kind of a mechanistic thinker. Anything I would do, I would think about, how do you turn it into a procedure or an algorithm? And the idea that you would get the machine to carry this out, immediately meant, well, gee, all the ways in which I solve problems, all the ways in which I go about thinking, if I can write that down, if I could describe that in some logical way, I can get a computer to carry that out. So it immediately went to the idea, frankly, of AI, and I just got more and more enamored with that. Eventually, I quit when I got into college, I was still, interested in medical school, but I got so enamored with this thing that I eventually quit that path and wanted to go to graduate school for computer science and specifically, artificial intelligence. So I was just completely overwhelmed by that whole concept.
So what exactly in the idea behind artificial intelligence is it that it grabs you and inspires you so much? Which aspect of it, perhaps?
I think it's a good question. I mean, I think there was certain just mechanistic things. It was very cool to be able to program a computer and see it carry out the tasks that you would give it. But there was also the philosophical view, which is more about understanding ourselves. What are the limits of our own intelligence? What is the essence of humanity?
Mm-hmm.
What would always strike me was, what is unique about us? What is unique about our humanity? And, when you think about, you go back in history and you think about what differentiated one human from another, and you can argue that it was strength and speed, but then it got to a point when we were able to create machines and we were able to leverage tools. It wasn't so much about strength and speed as it was about intelligence.
Mm-hmm.
Which humans are smarter, can outthink, can outmaneuver, can outstrategize other animals or other humans, and all of a sudden it became about, who's smarter. And we identified human superiority with intelligence superiority.
Yeah.
And but then when you start thinking, well, gee, if I can capture intelligence, I get a machine to be intelligent. What's left? What is it to be human? So very quickly, the science and the study of cognition and of artificial intelligence and getting computers to mimic human intelligence very quickly became a study of who are we, what's unique about us, what is the essence of humanity, what do we have to hold on to about ourselves. And so what looks like engineering and science ultimately becomes a study of human values, of morality even. In other words, what's unique about us even from a spiritual sense. And so it becomes a study, it becomes a humanistic study, a very broad humanistic study.
Mm-hmm. Mm-hmm. So perhaps now is the time to correct my starting mistake and tell us a little bit more about the difference between natural language processing on the one hand and voice recognition or speech recognition on the other hand, because in the popular mind, I think that most people perceive Watson as a basically voice recognition software. Why is that not the case?
Yeah, it's actually not the case at all. In fact, early in the project, we had a choice to make, which was, do we include voice recognition in the Watson system to play Jeopardy? And we chose not to. And the reason why we chose not to was because one of the really important challenges in AI was to when somebody starts speaking in natural language and they ask you just a question, open-ended question, we call it open domain question answering, with whatever language they choose, can you understand it and can you accurately answer it, regardless of whether or not you can understand the speech? Just understanding the natural language well enough to deliver accurate answers with accurate probabilities, those estimations that you're correct, is already an outstanding challenge in AI for as long as AI has been around, independently of whether or not you can get the voice recognition correct. So we really wanted to separate those two problems. Mm-hmm. Moreover, in the case of the Jeopardy challenge, we could have spent a lot of time recording the host, his name is Alex Trebek, recording his voice and getting the voice recognition the best we could. It would still be errorful. And one of the things that you'd like to do in a voice recognition system is get some feedback to say, well, did you say this? Did you mean that? Reduce the errors. And you can't even do that in Jeopardy. In other words, because the voice recognition is just assume that humans are actually, in fact, they're reading the clue. They're reading it. So even though the host is saying it, that's really more for the television, for the entertainment. Real Jeopardy players are getting the clue from reading it, from seeing the characters on a screen. They're listening to the voice to know when the buzzer is enabled. In other words, to know when they have the opportunity to buzz in, but they're getting the question from sight reading. So that's really what the game was about. So we said, you know what, let's focus on the natural language understanding. It's really not about the voice reco. We put the text-to-speech in because that's kind of how the game is played. In other words, you have to say your answer, you have to say your response, and there's really not much entertainment, not much a game if a contestant's not speaking. So we put that part of it in. So anyway, so it was a misconception in the beginning, but in the United States, we were very specific about and deliberate about saying that, this is not about the speech reco. This is not about the speech reco. And I think that as you get further from the center of the communication, we every once in a while we run into folks who didn't quite realize that.
Yeah. As I understand it, David, the idea behind Watson arose while you guys were at a bar, and there was the most recent Jeopardy episode played on the TV in the bar there. Is that the case?
So I wasn't there, but the story has been told that that's where it started, and in fact, Charles Lickle was a VP at IBM, and I think the really significance of that story is that there was an executive team at IBM searching for the next grand challenge, something that can follow in the footsteps of Deep Blue, the computer that beat Garry Kasparov at chess. And so they were looking for all kinds of ideas. And the legend goes that Charles, one of the executives on this team searching for the next Deep Blue, was at this restaurant, and they saw Jeopardy. Actually, what happened was the entire restaurant got up and went into the bar to watch television, and it was during that period where Ken Jennings, who was the reigning champion, it was in the middle of his winning streak. I mean, he was winning. He won over He won 74 games in a row, which is unheard of. I mean, the next most frequently, series of wins, I think, was 17.
Yeah.
So it was just an enormous thing, and it had really captured the imagination of the entire United States. And when he saw the restaurant get up and go watch, he went in to see it, and he says, "Wow, this is really garnering a lot of interest among the general public. Can we get a computer to play Jeopardy?" And so he went back and talked to the executive team and said, maybe this Jeopardy is the right idea here, because it's clearly getting a lot of interest.
Mm-hmm. And so in that sense, what would you say was the motivation? Was it mere PR to sort of ride on that wave of interest that was clearly visible across the United States? Was it sort of to accomplish the next step of scientific breakthrough after Deep Blue? Was it something else?
Well, initially it was the PR. Initially it was, can we do something cool in science that will get that sort of attention that Deep Blue got? And there was some, at least again, I wasn't involved in this initial thinking among the executives, but I think Jeopardy did come up under different, from different directions, different people suggesting it. But what happened with Charles was, he came back and said, "I got to tell you, this will probably really resonate with the public, because there are a lot of people really, there's a grand champion, there's someone like Kasparov in this that has this tremendous following, so this can have that kind of general public appeal." So, but then the question was, what does this mean scientifically? And so it went from this might have the right PR characteristics,
yeah,
but what does this mean scientifically? And then a bunch of people within IBM started weighing in on the science. And the general feeling was this was way too hard, and it was pure folly. It was too difficult. We had people, experts in search, experts in computer science, weighing in and saying, this is not the thing to do. It was way too much risk. Mm-hmm. We would in trying to take this on. And then it eventually got around to me, and I very much wanted to do it. And that's a whole nother story.
Well, that's my next question. Yeah, so that's the corporate sort of motivation, but what about your own personal story, your own personal motivation to do it?
So for me, it was absolutely irresistible. I mean, it was kind of like a must, for me, because I had been AI, my whole life really, from when I, again, was in high school, dreaming about this stuff. I've been building a team in one form or another, working on AI stuff for my whole life. It was my principal inspiration, and in fact, I had a team working on software architectures for natural language understanding, natural language processing, and just generally analysis of unstructured information. In other words, language, text, speech, images. Then I had a smaller team working in open domain question answering, but never really had a sufficient investment to really dig into the area. It was a typical kind of university or research investment of 4 or 5 people, And so when this came up, I said, wow, if IBM got behind this, I can really focus everybody on this challenge, and we can really dig into this and give this the kind of attention that I think it deserves. So it was irresistible for me. But of course, there were a lot of internal pressures in IBM. On one hand, you had the executive team saying, this can be the next Deep Blue. It ended up being much, much bigger than Deep Blue. Yes. But then you had a lot of technical folks saying, no, don't give Ferrucci any money. Don't let him do this. He's just going to fail. He's going to embarrass us all. So there was that kind of tension going on inside of IBM. I had my own team who didn't want to take. Many of them did not want to take the chance because they felt that they would be embarrassed, their careers would suffer from failure, et cetera, et cetera. So there was a lot of adversity to overcome within IBM to kind of ultimately get the real support needed to pursue this project.
And weren't you scared yourself that you might fail?
Yes and no. I mean, part of me certainly recognized the risk. But as I said to members of my team, trying to convince them, I said, where I came out on this is in 5 years from now, we can continue to kind of write the papers and do these incremental improvements on various components. But in 5 years, if we do that, I still will not be able to answer the question whether or not this challenge is possible. Mm-hmm. And I will be, in spite of how many papers we might write and, how many component evaluations we might participate in, let's face it, if we don't make a significant concerted effort and pull out all the stops, 5 years from now, we will know no more. If I came and asked you, is it possible to do the Jeopardy challenge, you will know no more than you know now. And I don't want to be there in 5 years. In 5 years, I'd rather have failed and know why this technology can't do it, or have succeeded at it and be able to tell people how we succeeded. I have no interest in spending 5 years and being no further along in understanding that, because this kind of question, AI, has plagued me for my whole life. Is it possible? Is it possible? Is it possible? If it isn't, why? And if it is, I want to be the one that did it. Mm-hmm. So that was the driving thing. And that compelled a lot of people, too. That kind of argument compelled a few to say, you know what, you're right. Let's just put it on the line. You know?
I can see how moving and inspiring it could be. So let's talk just for a second, just to touch on the resources that IBM provided for you. Can you disclose or can you talk about the general cost of the project?
I can't talk about the cost specifics, but I can tell you how the team grew. I mean, we started in 2007 with about 10 to 12 core people. By end of 2008, we had grown to about 20. Mm-hmm. And then ultimately, by the end of the project, again, I'm just talking about the core technical team. I'm not talking about marketing. I'm not talking about communications. I'm not talking about that stuff. The core technical team were up around the high 20s. So, over the course of 4 years, it probably averaged somewhere around, 20, between 20 and 25 people, mm-hmm. Maybe the low 20s.
And you mentioned the resistance that you initially felt at sort of the inception of the project, but did that change kind of towards the end? Did you feel that towards the sort of the end of the project, you had the feeling that like the whole company is sort of behind you and rooting for you?
Yeah, even before that, about midway through, about somewhere around mid to end 2008, John Kelly, who became the head of IBM Research, was very much behind this, and we were showing good progress. We were about to make external announcements, and once we started making external announcements that we were doing this, IBM was very much behind it. They were basically telling me, Dave, whatever you need, you have to ask for whatever you need to make this happen.
Fantastic. So, David, you've mentioned this term a couple of times, at least so far, artificial intelligence. So let me ask you first, what do you mean by that?
So, great question. I mean, I think there's lots of different ways to think about what AI or artificial intelligence really means. I frankly am enamored with, late John McCarthy's, definition in the 50s, which was, if you can a computer program, we can consider a computer program artificially intelligent if that program performs a task, that if that task were performed by a human, we would associate intelligence with the human, right? Mm-hmm. And I think that's a great definition because it avoids defining intelligence generally. And frankly, I think that was done deliberately, and there's certain genius in doing it that way. So it's a task-based definition. It avoids a general definition of intelligence. It says that human, intelligence is kind of a standard, and then it breaks it out and says, let's not try to define that generally. Let's take a task and say if a human could perform that task, and when a human performs that, we think, oh, a human's got to be intelligent to perform it. Now we get a computer. A computer can perform it a completely different way. Mm-hmm. But if a computer can perform that task, we say that computer is artificially intelligent. We don't say that computer has human intelligence. We say it's artificially intelligent because it can perform that task as well as a human. And for the human to do it, we say the human has human intelligence. We say the computer program has artificial intelligence. Mm-hmm. And I think that's a very elegant way to define it. And I think by that definition, it's actually quite liberal. Because, if a computer, you have a human who can, add or multiply two 20-digit numbers, you'd say, wow, that takes a certain amount of intelligence, right? And frankly, computers do that all the time without a problem. So the computer's artificially intelligence, it's performing this task. Chess is another great example. Jeopardy is another great example. Parking a car, driving cross country. Yeah, these are task after task after task. You look at it and you say, that program is artificially intelligent. I think it gets confusing when humans sit there and say, well, wait a second. When I understand how it's doing it very differently than a human does. And a human has a different kind of intelligence. Well, that's true, but that's not what artificial intelligence is about. And now you're really talking about what does it mean to possess human intelligence?
Yeah.
So when people say to me, does the computer program that played Jeopardy, is it artificially intelligent? I go back to McCarthy's definition. I say yes. Do they say, well, does it possess human intelligence? I say no. And when you ask me about something possessing human intelligence, I have a very different feeling about it. And if you want to ask me about that, I can give you an anecdote that helps, but I'll leave it at that.
Sure. I mean, if it's a short one, why not? Let's hear the anecdote.
Well, yeah. So the anecdote goes back to Tchaikovsky. I use music as a great example because I was my father used to listen to classical music all the time. I listened to it not as much as he did. My 10-year-old daughter plays it. She's a bit of a prodigy when it comes to playing the piano. But I was inspired by the story about Tchaikovsky, where he came up with this Sixth Symphony, and he spent a lot of time on it. And he was asked, how do you feel about, this creation? And he would go on and on about how important it was and how powerful it was and how it was a representation. He poured his entire soul into creating this thing, tremendous amount of emotional intellectual energy into creating it. And then he played it in St. Petersburg, and his first performance, the audience didn't like it. They jeered. They were like, unimpressed, didn't get it. He was, very upset by this. He said, how could they miss the significance and the importance of this composition? And he said they don't understand it. And he renamed it the Pathétique, the Emotional Symphony. And in his next performance, he explained how it reflected, the emotions of life and death, the cyclic nature that we go, of the ups and downs we go through in life. And then he played it, and they heard it, and they loved it. So what does this tell you? This tells you that I imagine if I expose a computer to enough compositions of music, and I train it, this is what humans like, this is what humans don't like, this is what humans think is good, this is what humans think is bad, this is what Tchaikovsky did over and over again, or Beethoven did over and over again, that I can probably create a computer program that create a variation that can actually create a composition that humans would like. Mm-hmm. But if the computer created a composition and I said I don't like it, do you think the computer would be able to now tell me why I should like it? The computer is not going to be able to create human value. They're not going to persuade humans of what humans believe. The human audience has to identify with the human experience. The human composer has to identify with the human experience. The human composer can sit there and tell you what it means to be human. They can say, here's how you relate to this creation. And only someone who has human experience could tell you how to relate to that human creation. Mm-hmm. You have to be you have to be human. You have to experience human intelligence and human values and what it means to be human to assign meaning. Mm-hmm. So a computer program can be trained to detect human meaning, but can it create and assign human meaning? Mm-hmm. And that's what human intelligence is.
That's a perfect little anecdote, by the way, because it's a perfect segue towards my next question, which is this. How important of an accomplishment is Watson in the greater scheme of things? And if it is important, is there understanding out there that it is?
So I think it is important, but I think maybe not for the reasons. I think the community out there is kind of bipolar. Some people look at this and go, "What's the big deal?" We have search and you could find things and documents, and I don't get it. And don't computers know everything anyway? And that kind of thing. And then there's the other extreme that is Watson understands all things and can converse in human language. These are two extremes. They're both wrong. The reality is somewhere in the middle. And I think the reality is that Watson is an important achievement. And it's an important achievement not because Watson can immediately understand arbitrary human language and converse fluently. It can't do that. And it would be great if we got there. And I think it's going to be a tremendous amount of work to do that. But what Watson has convinced me, the architecture in Watson, the way we approach the challenge, the way we architected the software, the reason why it got as far as it did in doing what it did in Jeopardy, suggests to me that there are ways and there are methods, and we can get to that point where a computer can converse more fluently in natural language. Will it understand language the way humans do? Will it connect words and phrases to human cognition? No, because it's not human. It doesn't have human cognition. Mm-hmm. However, I believe the methods we used and the way we integrated many, many diverse collections of natural language processing algorithms, the way we kind of modeled, almost the way Minsky talks about the society of mind, many, many different algorithm techniques. No individual one can solve the problem. No individual one, if you looked at it and you said, oh, it understands language. But by combining many of them and figuring out how to combine them and innovate rapidly on how to create, advance, and combine them in an architecture is exactly the method that we can use and will succeed at getting closer and closer to understanding and dialoguing fluently in natural language. So to me, what Watson represents is a success story in a methodology that has the best chance of succeeding at doing this. Mm-hmm. So it confirms that an approach can work. It confirms that this methodology, this architecture, and this approach to building language understanding systems, and frankly, more generally, an architecture for intelligent systems can work. We have to continue to pursue it. And in that way, I think it's very important.
And I want to come back to that in a minute, but before that, I want to ask you on that point here. So what do you say to people, for example, such as I just interviewed about 3 or 4 days ago David Chalmers, who is a very well-known philosopher of mind and is considered by many to be a thought leader in terms of consciousness and so on. And his take was like, well, David Ferrucci and Ken Jennings kind of convinced me that, his initial reaction was like, well, Watson is kind of a little more sophisticated statistical analysis and search engine. And I was like, well, David, I think it's a lot more than that, actually. He's like, well, yeah, David Ferrucci and Ken Jennings did convince me that it's a little more than that. But in the grander scheme of things, he doesn't think it's very important at all.
So there's lots of ways. Again, it depends what your objective function is, right? there's several ways in which it's very important. So one way, for example, is it's changing the level of investment that industry is willing to make in analyzing language. And in fact, unstructured information, not just language, but also speech and images. Because what it's doing is it's convincing people that that kind of investment will lead to value, will lead to the extraction of knowledge that I otherwise didn't have access to, that would allow me to make better decisions. So that influence that it's having on industry and not just business, but also the industry of science is significant because it's changing the investment paradigm. It's changing people's belief in what the value of the technology is and the potential of the technology, which changes how much investment is made. So it's already demonstrated value in that sense. Now, the other way I think it's important is it's changing the way people are thinking about how to approach this problem. So when I go to universities now are wondering, can a university do what you did at IBM? Because what you did at IBM was you didn't say parsing is the answer. Word sense disambiguation is the answer. Statistics are the answer. Heuristics are the answer. Knowledge bases is the answer. No, information retrieval. You didn't say any of that. You said, I've got to figure out an architecture that allows me to rapidly advance all these techniques and build an intelligent system that combines all of them to solve an end-to-end task. And you were able to make both the financial investment and the skill investment, which is non-trivial because now you're not saying there's going to be one professor who's a hero in this particular area. You're saying everyone contributes at each level, and there is no single hero in this. The hero is the team and the broader investment in building that larger system. People worry that they don't know how to make that investment. They don't have the right incentives to make that kind of investment. And I think AI systems in the future have to be like that. And you have to figure out how to manage the people and the skills and the talents to create the right incentives to build and deliver projects like that. And I think Watson's success gets people to think differently about how to innovate, and particularly how to innovate in this area. In that way, I think it's very significant. It's also significant in a third way, which is this is Watson, contrary to popular belief, is not purely a statistical machine. It doesn't sit there and say, here's a library, a giant, let's say, database of question answer pairs, and I'm going to learn statistically how to map features in the input to the output. That's not actually how it works. That technique is used in certain individual components, but if you looked at Watson as a computational machine, that's not what it's doing. It's actually building, if you will, an inference graph from the input to the output, where every link in that graph is evidenced by natural language and there's naturally occurring knowledge. It's evidenced by a passage, by a fact in a database, by 5 passages and 5 facts in a database, where a confidence measure that says, I believe, with this degree of confidence, I being the system, with this degree of confidence, that this piece of knowledge supports this link from some subset of the input to some node in the output or some intermediate node of the final node. So I'm not acquiring axiomatic knowledge from a team of knowledge engineers. I'm not explicitly trying to encode knowledge to solve this problem. The machine is dedicated to finding and assessing naturally occurring knowledge to build that inference graph to input and output. So in the end, I can actually explain to a human, here's why you being the community of experts who talk about this topic, here's why you believe this input maps to this output. I've collected, I've analyzed, and I've scored it, and I'm giving your knowledge back to you, but now in an organized inference graph that convinces you why this is. And the reason I could do that is because I can understand that knowledge that you've created well enough to build that inference graph. This is really a very different paradigm. It's not an expert system. It's not a knowledge-based system. It's not search. It includes all of that, but it's not any one of those things.
Yeah, and I have to say that Professor Chalmers's sort of pessimism or skepticism on that and I told him, reminded me very much of Noam Chomsky. I think when he was discussing Garry Kasparov's loss to Deep Blue, when he said that he was totally unimpressed by it because for him computer beating Kasparov in chess was as interesting as a bulldozer winning the Olympics in weightlifting, for example.
Well, that's an interesting comment because when I kind of give my talk about Watson, one of the things that I talk about is the comparison between chess, and language. And I think when you go back and you understanding language, and I think when you go back and you look at chess, after you kind of get over the fact that a human champion has been thrown by a computer, and you kind of get over that, and then you step back and you look at the chess problem. What's really more amazing is not that a computer can play chess; it's more amazing that a human plays chess. Because of how mathematically rigorous and how well defined the problem is, and how to play it you have to kind of navigate this well defined, albeit enormous, albeit well defined search space, which is really a perfect problem for a computer. As opposed to a human. So it's like the human that's the oddball. And I think that's why we were so impressed with human champions, because most humans can't do that. We're not impressed with people who could fluently dialogue in natural language. We're not impressed by that at all. Yeah. Because most people can do that. But can a computer? Not even close. So it's kind of interesting how that got flipped.
So let me ask you this, a little bit of a different take in terms of the importance of Watson. Can we speak of a sort of a progression of perhaps what some people would call our benchmarks towards the technological singularity? So, for example, a couple hundred years ago, we had, the spinning jenny, very sort of non-intelligent, kind of repetitive machine, which kind of was one of the first ones to start replacing humans at their own domain of activity. Then, eventually we had, laser welding and whatnot, industrial productions, and then intelligence was considered to be that entirely human-dominated domain, perpetually for some. Then we had Deep Blue, which defeated Kasparov, I think in 96 or 97. Now we have Watson, who defeated Ken Jennings in Jeopardy. Is the next step the Turing test, for example? And are all those events kind of pointing towards a technological singularity, in your opinion, or not?
So I don't know if the next step for me is a Turing test. I mean, I could see a number of intermediate steps before the Turing test. I mean, I think I'd love to see a computer dialogue fluently on a topic that was almost indistinguishable from a human, but I have mixed feelings about that. On one hand,
wouldn't that be the Turing test itself then?
That would be the Turing. That's what I meant. That would be the Turing test. I think there are intermediate steps toward the Turing test. One of the problems I have with the Turing test is that, this notion of indistinguishable from a human, it sends you down a path of modeling lots of quirks. Frankly, that I don't know, that you can play all kinds of tricks with that I don't know that are ultimately particularly useful.
Yeah, I see.
And, because not all humans I speak to, not all conversations with humans I speak to are particularly productive. In fact, the majority of them are probably not. So, and they're really all about, sort of human quirks and emotions and all this other kind of stuff that is, and I think if you really want to focus on indistinguishable from humans, you can go down a rat's nest. If you want to focus on a rational and useful natural language dialogue, right, then I find it extremely interesting and extremely challenging and extremely useful, and frankly, very quickly, noticeably not human. Right? So if you go, and that's why it depends on how you define the Turing test. Because if you go like this, Star Trek Next Generation, and you see these dialogues with the computer, these are information-seeking dialogues. The computer is very rational, takes you through, understand what you're asking, the content, how to organize it, how to present it, how to, ask the follow-up question, how to disambiguate, and you sit there and go, wow, this is a fantastic, fluent, natural language dialogue where I got what I needed at the computer. The computer was very intelligent, helped me a lot, but that ain't human.
Yeah, just like data, for example, right? You can converse with data, but it's very clearly that he's not human, just based on the way he speaks and the way he reasons and so on.
Right, exactly. So, so that's what I worry about when I go to the, you jump right to the Turing test. But, I'd like to say, for example, can I create a machine that can understand natural language well enough, not just natural language, structured and unstructured knowledge, combine, understand it well enough that I can converse intelligently with it to help me solve a problem, and I can converse in natural language. It's obvious that this thing's not a human, but boy, it understands what I'm saying. It understands what I read, what it read, and it can help me, make a decision with that fluid dialogue. That I think is a more important thing to ultimately go after than if you get too nuanced around the Turing test, creating something that's indistinguishable from a human.
Mm-hmm. So perhaps now is the time to ask you then, what's next for Watson and what's next for David Ferrucci?
So, that's kind of where I'm very technically oriented. I go down to the nuts and bolts of what the machine is really doing. And for me, I would love to see it go, roughly where I just told you, which is it's almost like I want to take Watson, I call it Watson 2.0, but what I want Watson 2.0 to be able to do is to be able to not just take a targeted question, but really take a problem scenario. Here's my problem. Like in healthcare, here's what I can tell you I know about my patient, or what you know about me. And they would tell you this stuff in natural language, maybe give you some structured information, like here's the results of these lab tests, let me tell you what my experience has been, the symptoms, the various observations I made about the patient. And I want to engage in a dialogue where the computer comes back and says, well, here are the 4 possibilities I'm considering. And the difference between these 2 possibilities, the reason why I'm thinking this one's more likely than this one, is I have to focus on these 5 factors you described. And, if you were able to tell me a little bit more about the 3 last places the patient has visited, then I would prefer this diagnosis over that one. Mm-hmm. And here's why. So helps you zoom in on the information that is going to help you distinguish between one answer and another and lead you to the evidence. By the way, I just read this recent journal that suggests that it may be this reason over that, it may be this answer over that answer because of this reason. Take a look at this. Yeah. Okay, and there's this much evidence behind that. It may be suspect because if you read the conclusion here, in other words, just like it was talking to an expert, and I want the system to be able to do that without having explicitly axiomatized all that knowledge. Mm-hmm. I want it to be able to do that by having just given it the reference books, the journals, and the text, the same knowledge that other humans have created for me to make me an expert. Mm-hmm. That would be unbelievable. That's where I want to go.
I agree, and that sounds an awfully lot like the X-Prize, what was
tricorder?
Qualcomm Tricore, yeah.
Well, I talked to the X-Prize folks about this when they were formulating that, and I guess largely because it was funded by Qualcomm, there's this focus on the device itself. And my personal interest, a device like that would be very, very cool, don't get me wrong, it would be fantastic. But, my area of interest is not in the device itself. It's really in the ability to absorb all the knowledge and to reason over it in sort of its natural form or its naturally occurring form. Mm-hmm. And it's not about the device. And I wanted them to separate the device from the reasoning component completely, where you evaluated the device independently of the reasoning component. Mm-hmm. So, like, you would evaluate the device by saying, I'm gonna have competitions for the reasoning piece completely separate, and I'm gonna do cross validation. Like, how would the device perform with this reasoning component? How would it perform in this reasoning component? So they were not tied together that way.
Yeah.
That's not quite how they went with that. But I would have, you know what I'm saying? In other words, I would have liked to see the evaluation completely independent, where one component is completely independent of the other, and you could do the various, you can evaluate matching them, across each other.
David, time is advancing here, and I think we only have about 5 minutes or so left from our interview. So I'd like to ask you the last three questions. And I just want you to, the first one will be, I just want you to say a couple of words on the technological singularity in general and artificial intelligence perhaps in particular. And when I say artificial intelligence, I mean general artificial intelligence. What do you think of those two as concepts? How realistic are they in your opinion in general, and how far, if they are realistic, how far we could be perhaps?
Well, can you define for me, because I've heard many different definitions, and I just want to level set. What do you mean by the singularity?
Well, there's at least three general schools of thought here, but I think the most pertinent one for our conversation would be the birth of general artificial intelligence. That is, human level artificial intelligence or greater.
I don't know. I don't know how to get there. The way, when you work with the computer architectures the way they are and software architectures the way they are, and as I went back earlier in the conversation, I talked about the Tchaikovsky anecdote.
Yeah.
I believe that we can continue to make computers better and better at detecting meaning, but not creating. In other words, not assigning and creating meaning. In other words, and this is because the architectures we have today, both hardware and software, are not human. They don't store human experiences the way humans do. They don't experience the world the way humans do. They're not holistic creatures. When you talk about what it means to have a human intelligence, I don't know how you separate the human intelligence from the human experience. So human intelligence to me means human DNA, basically. Because I don't know how to separate, frankly, my rational mind from my emotional mind, from my physical being. So much of my human intelligence ties all those things together into a holistic, agent. And I don't see a path where we are with computers today to get to that, what I would consider that holistic human intelligence, which I don't think you could separate the rational mind from everything that else that goes on in human cognition. And so if you asked me, what makes human intelligence, I'd have to, in a nutshell, say human DNA. Now, if you say, well, the path is to actually mimic the human being, to go down to the level of creating a brain and creating, if you will, and now I'll put it in quotes a little bit, the human being through the human DNA, recreating the physiological being, then it's okay, but that's not getting there from today's computer hardware and software architectures. That's getting there from mimicking the human being.
What about just recreating the brain either via whole brain simulation or emulation?
Please don't put me in that box. Because, when I was a teenager, I actually drafted a horror story, but I'm sure it was mimicked over and over again in different, science fiction novels of, someone, putting you in a box like that and detaching you from everything else that makes you human, right? So now you have a human brain without any connections to anything else being human. I think that, can be horrific, particularly if it, it had consciousness. If you could find the human brain that doesn't care about any other aspect of its humanness, then, maybe it wouldn't be as horrific. But, in all fairness, there's legitimacy, in my view, in approaching intelligence by looking at the human brain and saying, how do you construct it neuron by neuron? And how do you create intelligence with this kind of wetware type architecture? And that will teach us a lot about ourselves, and it'll teach us a lot about intelligence and architectures for intelligence, and I think it's irresistible to pursue that. I, for one, can't tell you, I can't estimate, if you follow that path, how long it will take you to get to human intelligence, because I don't know if that architecture, if that neuronal architecture, if you will, is sufficient for really capturing intelligence. Because what's in there, how is it trained? How it's trained may be so dependent on its contextual realization in the human body and in the human experience. Yeah. Right? So what is the software, and how do you train that software? Right? So how do you separate those two things? I don't know. Open question. You'll learn a lot. I think you will learn a lot from doing it, but I don't know, how long it's going to take you to get there.
Yeah, that's the really big question there, and I think we certainly don't have a good answer at all. So, but let me ask you the second last question here, which is, where can people who are interested in you and especially in your work, what's the best place for them to go and find more about what you do?
Well, there's going to be, in terms of the Watson stuff, in March, sometime this month actually, there'll be a publication. The IBM Systems Journal will be a collection of about 17 papers, technical papers that describes what we did on Watson. We will be publishing kind of a white paper on Watson 2.0, which will be available from, my very scant, IBM research page. There's not a lot there right now, so you won't find that much about it. But if you, Google me, what can I say? And, you can find stuff out. But I think the most interesting things would be about Watson is to look at the AI Mag paper that came out, look at the Systems Journal the IBM Systems Journal that will soon come out, and we, look for the Watson 2.0 white paper that will talk about where we're taking the technology. That will also come out. So those are the best places to find it at this point. There's no easy one-stop shopping.
I wouldn't even ask you about that, because I think that's the perfect hook for people to go and chase after that information and see what's up next in the future for Watson 2.0. But David, the last question that I always ask of my guests on the show is this: what is the single most important thing, or the single message that perhaps you would like our viewers and listeners to take away from this interview with you today?
The message is you can't give up on the big challenges in artificial intelligence. And in fact, it's more than not giving up on them. I think the scientific community has to be compelled to pursue the big challenges, because that's where we're going to see the advances. That's what's going to excite not just ourselves as scientists and engineers, but is also going to excite the next generation. Mm-hmm. They need to see. I was shocked to find that a lot of people are, in spite of the ubiquity of computing devices in our world today, from smartphones to mainframes, whatever, to the internet, that less people are excited about being in computer science than ever before. Mm-hmm. Big drop in enrollment and interest in that area, not really being taught in high schools anymore. And
perhaps you're referring only to North America, though, not to India and China.
I am referring to North America. But, I think there is a phenomenon that the more ubiquitous these things get, the harder it is to kind of excite people about what's really interesting in computer science. Mm-hmm. And I think that's actually an odd phenomenon. I wouldn't be surprised if that's not limited just to the U.S. And what happened with Watson is, because I had high school students come to me and say, "Wow, Watson really excited to be about computer science," and I was like, "You're kidding?" I said, and they said, there's computers all around you. Without your smartphone, what about, you can, but that, we all know about that stuff, but this is really interesting because it makes us think about what's not done yet and what can be done and where this thing could kind of go. And I was kind of shocked by that. So I think, my message is, we've got to do those big things. We've got to do those big things that inspire people and make people really scratch their heads and go, wait a second, you mean, there's a chance computers can do that? Or maybe they come back and they say, you mean computers can't do that already? I didn't realize that, because they should. They should be able to do that. And so it really kind of opens their minds up to say, I got to get into this. This could be really exciting. This could be really important. And we're not going to do that with the small projects. We're going to do that with the big projects.
Dr. David Ferrucci, thank you very much for being with us on Singularity One-on-One today.
Thank you.